All right, hello everyone. Welcome back to my daily coding series. Today is day 53. I'm going to look at a stack problem today. I have at most 30 minutes to do this problem. So we have to design a stack class that supports the push, pop, top, and get min operations. Okay, so we have min stack, which will initialize the stack. Okay, so initialize, push element, remove the element, gets the top element, retrieves the minimum element in the stack, and each function should run in O of 1. Okay, so basically we are basically making a min stack. So this, we need to always know what the minimum part of the stack is. Okay, so to be honest, I don't know exactly how this is going to work. So obviously, all right, so let's just look at it from a human perspective. So if we push 1, 2, and 0, and then we called get min twice, we'd want to return, does it pop it? Gets and removes and retrieves. So here when we get min, it just returns 0, pop, top. Okay, so get min doesn't pop anything, it just returns whatever is the minimum. So we need to know what the minimum is at every point, but it has to run in constant time. So this seems like a case where you'd use like a heap, and I know that takes it takes, I think it's constant to get the minimum, but then to rebuild the heap, I think it's log n. This does seem like a useful data structure if I could implement it. So this is just the stack as we add the order. Like, so what if we did 2, 0, 1? We still should return 0. Should we just return? Should we keep track of the minimum elements? Maybe. So if we do 2, 0, so we'll add 2, so the min element is 2, then we add 0, and then that goes to 0, and then we add 1. Minimum element stays the same. So if we get minimum, we can just return 0. If we pop 1, if it is, okay, so yeah. Okay, so if we have 2, 0, so I think we add everything that was a minimum in like another stack. So we'd have 2, 0, so we add those two, and then 1, we don't add 1. So this tells us like the order of minimums right now. So if, yeah, this looks good. So then we pop 1. So if we get min, we'll just return the top of this stack. If we pop, we get rid of this. If we pop, if this is also the top of the minimum stack, we pop the min stack as well. All right, I'll try implementing this. So we'll have another stack. So we'll have like normal stack, and then we'll have min stack. So we'll have 2 stacks. So push, we're gonna add an element, and then we also need min value, which will initialize to infinity. All right, so push. So we're gonna add stack.append value, no matter what, and then we'll check if value is less than min value, probably or equal to, right? Because if we have duplicates, for instance, 2, 2, 0, 0, 1, our min stack should reflect that we have 2 of those. So then this is not the minimum. This is the minimum, so if we pop it, we still have another 0, so we do want to add duplicates. Okay, so if it's less than that, then we're going to update min value to be value, of course, and then we're going to add it to min stack dot append val. So that's still constant. Pop. So pop is going to stack dot pop, and I'll say top value. We also need the self keyword for all of these. Okay. Equals to self.stack.pop. And now we want to check, is the top value the same as the min stack top value? So if top value equals self.min stack of -1, so if they're the same, then that means we just pop the minimum value. So in that case, we also want a self.minstack.pop. Okay, top. So this will just return return self.stack of -1 index. So this is just the topmost thing. Get min, we're going to return self.minstack of -1. So whatever's at the top of this stack is the minimum, not necessarily what's at the top of this stack. Okay, this looks like a good place to get started. So let's check it out here. I must be missing self somewhere. Min stack has no attributes. Stack. It doesn't. Typo maybe. Line 21. Self.stack.append value. So this doesn't work. Does that work? I thought I would need self. Yeah, stack. Do I have to say self.stack here? That looks right. Okay, so let's try that. Wrong answer. So, all right. So we have to make sure when we pop, what does it say? So if we try to if we try to pop from an empty stack, okay, pop, top, and get min will always be called on non-empty stacks. So how is this out of range? Min stack of -1. All right, so I'm guessing or should I just check if it's the min value maybe? Yeah, because I'm not updating. Am I not resetting the min? Well, this would work. But I'm not really using min value. Maybe after each call, I can print, just to help debug it, I can print out self.stack and self.minstack. Self.minstack like this. And see where exactly my current behavior differs from what I am expecting to happen. So I'll submit that. I'll use this as a test case as well. So we're getting out of range. So we push -1. Yep, that looks good. We push 5, so it doesn't go in the minimum. We push 0, it doesn't go in the minimum. Oh, I see. So we push -1, push -5. That goes in the minimum. We get min. Get min returns -5. That works. We pop. So we're going to pop -5 from both of them. We pop. All right, so I'm running into a problem. So if we have, let's say like 4, 2, 3, 1, our min stack will be 4, 2, and 1. So if we pop, or even if I just had, let's say we had 1, 2, 3, 4, okay? So then we would have, so we would add 1, we would not add 2, we would not add 3, we would not add 4. Okay, so then, well, no, that would work. I think it's the problem is if we have some big values over here, like, yeah, let me just illustrate it with what I was saying. So with here, so we encounter 4, that's the lowest. 2 is the lowest, 3 is not the lowest, 1 is the lowest. Okay, so then if we like pop these, it does seem like it is working actually, so let me continue. So we pop -5 and now we're here. We get min, we pop again. Okay, so that works. When do we push 4? So we push 4. 4 gets added to the stack. Okay, so we're not adding to the min stack here for some reason. Maybe as we pop, we're not updating the min value again. So min value is staying at the old one, but it should be updating. So yeah, right. So when we pop a 1, our new min value has to get set to 2. So we have to say self.min value equals the new lowest one, like that. And that should fix it. Okay, it did not fix it. All right, so we need to check if it's empty, probably. So if self dot min stack. So if it has something, we'll set it to the new thing. If it has nothing, we'll say self dot min value equals float infinity. Okay. All right. Nice. So that was 15 minutes, not bad. Okay, so I think, yeah, everything here is O of 1. Basically, the trick is you have to use 2 stacks. One that keeps track of the order of your minimums, and one that just does every value. Yeah, and then the key is too, so if you pop a minimum, you have to update the new minimum, and if it's empty, the new minimum would be infinity, and you need to do that. So when you push another value, it checks against the new minimum and not the previous minimum of the whole collection here. So, all right, guys, that's day 53. Thanks for watching. Sorry, it was a shorter episode today, but nonetheless, I think it was a good problem. So, thanks for watching.